Alright gang, here's a quick video on factoring, factors, and the next part of our notes in the packet, using the greatest common factor of monomials within a polynomial to actually factor a polynomial. So to start us off, just kind of understanding what a factor actually is. So hopefully you went through some of the video and note work on con yesterday. If not, hopefully you do so in class today, and we'll find some time if needed tomorrow. But so factors, what makes it a factor? Like, why do we call things a factor of something? So 3 and 2 are factors of 6. And the reason we can say that 3 and 2 are factors of 6 is because 3 times 2 gives us 6. Like 6 is created by 3 times 2. So we can take 6 and break it into these two factors. So when you think of 6 in this situation, 6 is the product and 3 and 2 are the factors. So we're going to look at our understanding of taking two things, putting them together to get something, and then doing that in reverse to get its factors. So it's important to understand the multiplication we've been doing over the course of the week. You know, we've been multiplying monomials times monomials, monomials times polynomials, and then special cases. And understanding each of those will help you understand this factoring piece. So here's just some examples. So finding factors of, like, what are the factors of x squared? So x squared we can break apart into x times x. So we just understand what creates x squared, or what creates x cubed, and that's x times x times x. You know, the same thing goes with these variables that are raised to an exponent as just common numbers. So if I want to think about factors of this monomial that has a coefficient and a variable component, 6 can be broken into 3 times 2, and then the x squared can be broken into x times x. Or this one, 9x squared y squared. How can I break that apart? Well, 9 is broken into 3 times 3, x squared is broken into x times x, and y is broken into y times y. So this would be all the factors of this monomial. Now, okay, so hopefully you have an okay idea on this. Let's look at what's called the greatest common factor. Now, when we talk about greatest and common, we have to be able to compare things, and so we're looking at two values. So again, it could be numbers. What's the greatest common factor between the number 4 and the number 18? Well, I know 4 can be broken into 2 times 2, and 18 is 2 times 9, and 9 is 3 times 3. So 18, if I talk about its prime factorization, which means the prime numbers that create 18, would be 2 times 3 times 3. So I can look at, okay, what's the greatest common factor between 4 and 18? Well, here's the factors of 4 again, 2 and 2. Here's the factors of 18, 2, 3, and 3. So the only thing that they have in common is a 2. So 2 all by itself would be the greatest common factor of those two numbers. 27 and 36. You're probably getting the idea of this. Do I need to go all the way down to their prime factors, or I can think of numbers that I know go into both 27 and 36? That's another way to think about a factor, is what is both of these, or what are both of these divisible by? And 27 can be broken into 9 times 3. 36 can be broken into 9 times 4. So 9 is the greatest common factor between 27 and 36. Now I could choose 3. 3 goes into both of those, but it wouldn't be the greatest. 9 is the greatest. All right, what about x squared and x cubed? Now when we get to these types of comparisons, people get a little thrown off. They're not quite sure. They're like, well, they both have an x. Well, x squared is x times x. X cubed is x times x times x. So both of these, x squared and x cubed, have factors of 2 x's. And so x squared would be the greatest common factor between these two monomials. And once you kind of understand this, you can look at it and go, okay, yes, I got an x squared, and x squared is part of x cubed. It's x squared times x, so they each have an x squared term. Okay. So there's just a quick rundown on what it means to be factors, and then comparing factors to talk about the greatest common factor. Let's look at factoring now, related to a polynomial. So if I want to look at the greatest common factor of a polynomial, so you're not being asked to factor something out yet, you're just looking at each individual term. Okay, so when I look at this term, 2x to the fourth, and then this term, 10x squared, and this term, negative 6x, what would be the greatest common factor for this polynomial? Well, I know that 2, 10, and 6 each have a factor of 2. 2 is 2, 10 is 2 times 5, and 6 is 2 times 3. Now each of these also has a factor of x. Now I'm not going to write out all the x's because there's 4 of them here, 2 here, and 1 here. But this term, negative 6x, only has 1 x. So that is going to be the largest amount you can take from each term. So they each have a 2, and then each have at least 1 x. So 2x would be the greatest common factor for this polynomial, for all the terms in this polynomial. Okay. Now the next step is being able to take this understanding and factor out. So that's this last piece. Use the greatest common factor to factor a polynomial. So essentially we are doing the distributive property in reverse. So we can use our multiplication to be able to check how we did factoring. So here's another example, 4x cubed minus 8x squared plus 12x. All right, so I'm going to be brief on this. I'm going to say, okay, 4 has a factor of 4. Okay, 4 times 1 is 4, or 4 goes into 4. 8 also has a factor of 4. It is 4 times 2. And 12 also has a factor of 4. It is 4 times 3. And again, each of these terms has an x. One x cubed, but still, again, that just means x times x times x, and x squared is just x times x. And then there's only one single x in the 12x term. But there is at least 1 x in each term. So now, if I look at it this way, I can understand, all right, there is a factor of 4x in each of these 3 terms. And I can pull that out. So it's going to remove it. So if I remove 4x from this term, what's left? Well, I took the 4 and I took one of the x's, so the only thing left is x squared. And if I took a 4 and I took one of the x's from this term, so I take the 4, I take one of the x's, what's left? Well, 2 is left and one of the other x's, so it's still minus, so minus 2x, because that was what's left. And then what's left in the last term, if I pull a 4 and the x out, well, the only thing left is that 3, so plus 3. So I took that greatest common factor which was 4x, and I pulled it out of each term, and then I'm just writing down what's left. So the way to check this is to actually then do the distributive property, and I should get the original polynomial back. So if I did 4x times x squared, I'd get 4x cubed. That's what I started with. If I did 4x times negative 2x, I get negative 8x squared. And if I did 4x times 3, I get 12x. So I get the original polynomial. So this would be using the greatest common factor to factor this polynomial. So I'm separating it into two parts that if I multiply them again, I'd get the original one back. Okay, so that's the same thing as going, okay, if I take 6 and I break it into 2 times 3, I'm breaking it into its factors, and these are factors. Okay, so hopefully that's enough. I just hope to get you guys through that page 7 in the note packet. So if you followed the video, I did some of the examples right from the packet. You can just either copy them back onto that packet, watch the video again, or just look at the answers real quick. It's fine by me, but then finish the rest of those. And hopefully I can see how you guys did tomorrow. Hope you guys are doing all right. Look forward to seeing you on Friday. See ya.